Hi and welcome to a new video Python and Linux on this channel. Today's video we will continue with our second part of bouncing ball. In the last video we made it to visualize movement of ball in terminal, and this time we will do it in Jupyter Lab. So as you can see, I have here notes I took setting up. Just move this to another screen and we're gonna start this virtual machine that is mainly built for testing purposes. Let's start terminal with Alt space, then search bar on top Debian. Let's open terminal, and if you go incus list, we're gonna see here we have one testing environment that is made just for these purposes. Let's enter it with incus exec. Name of the virtual machine is the testing, so let's just testing, and we're gonna do like this bash, and let's enter. When we enter incus, we are at root level. Clear the screen and let's check what we have there. So we have here two directories for testing purposes. Let's make new one. Let's call it bouncing ball. And now, as you can see with ls, we do not have anything there. Clear the screen again. I will just zoom a little bit just for you to see on video better. Next step, what I need to do is to set up Python virtual environment. Let's just do like this: Python vm.venv. This .venv will be our hidden directory that will hold our virtual environment. Press enter. I'll take a moment, create it, and if we do ls la, you're gonna see it. Because if you do not do this LA, I'm not gonna show it because it's hidden. You see the dot ls, nothing, because there is nothing is visible. Let's clear the screen, and to activate virtual environment Python, go source, then .venv bin, and then activate. Press enter. You're gonna see it here that it's active environment. Next step is to set up Jupyter Lab so we can easier work with visualization. Let's do that. Pip install Jupyter Lab all together, and then press enter, and it's installing. Let's wait for a moment. Okay, now we have installed Jupyter Lab. Let's clear the screen and let's proceed. To activate Jupyter Lab, you just need to type Jupyter space lab, and now you're gonna see that it started. But I made a mistake because this is in container. So let's repeat this step. Let's stop it. Control C. Yes, we stop. And let's clear the screen again. What I made mistake, because this is virtual environment incus, so we need from our host virtual machine to see what are we doing and to access it. And instead of just typing Jupyter Lab like this and pressing enter, I need to add IP equal and then 40. Then we put a port, gonna be 8888, standard port for Jupyter Lab, and then we just gonna add here no browser. And this is the setup that we need to do because I need to access it from host virtual machine. Let's press enter now. And now if we open Firefox, we can go to that page. It is HTTP, and then we need IP address of the container. And let's check cus list to see like this our IP address. So this is the IP address that we need to open. Copy it, and we go to this browser, and as we said 8888, you can add here as a lab. Press enter. Okay, this is new, never happened before. Okay, we're back. As you saw, I had some issues that were not issues because previously I never had experience where it asked for this token, and at the end it was not actually any problem. I just needed to take this token and just copy paste in login page, and we are there. Now we are in lab. As I said previously, I never had that page where it asked for token, but for everything there is first time. That's how you learn, by failing and succeeding and never giving up. And we are here. Now let's start with Jupyter Lab and visualization of our ball. that we previously made. This is a short introduction to Jupyter Lab, and when you open this page, you just have here console, notebook, and these others, terminal, text file, and so on. Just open this notebook and see this one. Let's rename it. Let's name it Getting Started. Enter, and when we go here we can write in Markdown or in code raw as well. Let's do Markdown first. Let's put headline basics with matplotlib. Let's press Shift Enter, and when we press Shift Enter, it's gonna go to next line. First step should be to install matplotlib and other libraries. So let's proceed with that. Exclamation character pip install. Just a note, when you're installing libraries, you can put like this. This means that it's gonna quietly install in the background, and you're not gonna see here anything what is installing. But to be able to see that it's working, just this time I will leave this one without Q, and this one numpy I will put Q. So let's press Shift Enter and wait a second. As you can see, it's installing. You can see now it's installed, but I do not want to see everything here written like this, so I will just put Q as well on matplotlib, and it's not gonna be shown. So quietly installed at the background. Let's import libraries. Before we do our visualization of a ball, bouncing ball, let's introduce a little bit matplotlib, how to do and work. We can x-axis like MP, line is, and then we can give it some value. Let's say 0.2 times NP by x-line, y-axis, NP in open close brackets, x times, let's put 56, because we imported matplotlib as PLT. Plot it to the screen with x and y. Now PLT show. Let's press Shift Enter, and we have an error. Okay, typo error here. Shift Enter. Now we can see it. But we can do a little change. Let's say we put here 100. We can put 500. We have now much more. But let's say 20. And we have here bunch of up and downs. I mean, how to create a figure containing a single axis, and do figure axis equal PLT, again subplots, open close brackets, go next line, axis plot, and now let's give it some value, square brackets. So this is for x, and now let's give it for y. And now we can show it on the screen again. PLT dot show, open close brackets, Shift Enter. We can change like this value to 1. Any value we can change, and it's gonna change, and it's gonna update. But as well, we can add more. Let's say I add here one more, 505. Press Shift Enter. Now we have 2, as you can see. If you want to just show single axis figure, you can just do like this, and PLT show, open close brackets, press Shift Enter, and now we have it empty, no data, anything. You have as well figure with multiple grid axes and much more. Let's do one more example like this, and let's put it as a markdown. Shift Enter, and now let's do it. We can add like this a value, let's say 2 axis, and let's say 5. If you do Shift Enter, you're gonna get, as you can see, 2 and 5, and change it by 2. Shift Enter. If you want to learn more, just go to official website. You're gonna see here everything. We have tutorials or getting started. First, where I started is here. I went to get started, and then, as you can see, exactly the plots that we showcase in this example, and much more. So if you want to learn this library, just go to this website, and you're gonna learn much more. Just follow one by one, and you can do a lot. Now let's proceed with our ball visualization. We will not do any more examples in matplotlib. Okay, I did not change to markdown. Let's redo our visualization from previous video. Little bit different. give it a position again to 100 meters, give it velocity 0, so it's gonna start at 0, and let's give it gravity minus 9.8. Because this is gonna be different than visualization in terminal, we need to create here a list. Let's just create position, a list. It's gonna be empty list. We give it a frame to start at 0, and now we need to do for loop. In previous video we did while loop and it looped forever without stopping. This time I'm gonna change it to for loop. I'm gonna give it for I in range. I'm gonna limit to, let's say, 100 times. So let's position equal position plus velocity if position is less or equal 0. We want to update velocity equal velocity times minus 1. So what this line of code will do, it's gonna flip the ball to go up. Previously the ball will gonna fall down, and then when it hits 0, so ground, it's gonna flip the ball to go upwards. Velocity should be calculated first to flip the bounce, and as well it must multiply with minus 1. We're gonna update the velocity equal velocity plus this time gravity, and this gravity should be placed after the bounce, so after hitting the ground. Now we're gonna append to the list, append, and we're gonna append position. Every time the ball bounces down, we're gonna input current position of the ball into this position list that is currently empty. Let's do the same with frame. Now let's press Shift Enter. Okay, we have some error, typo error, as I can see. Velocity, it's not velocity, it's a velocity. Quite often typo errors, but it's okay. We can fix everything. So let's just do now. Let's take y-axis equal position, and we're not gonna take position from the position that is here 100. We need to take position from the list that we are updating. So we're gonna put position list as well. We need to do same for x-axis. Now we can print it to the screen. Curly brackets, open, closed, then we give it x. Did we say x? Yes, frame x. Now we can print it to the screen. As you can see, frames starting from 1, 2, 3, and so on, all the way up to 100. Then we have position that is standing on 100. Something's definitely wrong. Let's fix it. It should not be all to 100, so it's just standing. I did something wrong. Let's check. Problem is that I do not see the problem. That's the problem.
A few moments later.
Okay, we fixed the error. Error was again typo error, as most common one. The error was here, was written velocity instead of velocity. So it did not calculate velocity plus gravity. It did not update position list, and it was printing just 100 as a starting position that we have here up. Okay, now when it's working, as we can see, we have frames from 1 to 100, and we have position 190.2, 70.6, and so on. If we want to make it more realistic, let's say, because ball when it's bouncing, it's not bouncing equal strength always, and every bounce loses a little bit of the strength in that bounce. We can do that here, but let's do first this one. Let's PLT show, open close brackets, and let's show it on the screen how it looks like. Now let's wait for a moment. Okay, sorry, my mistake. Not show, PLT plot. Then we plot x and y axis. We have it. We have our visualization of the ball that is starting here at 100. You can see here 100, then going down to 0, going up to 100, and always like that. But now it's just bouncing equal strength. It's always bouncing at the same height and same strength. You throw any ball, it's not gonna bounce equally. we can change this velocity equal velocity times 1. We can change that, let's say, to 0.8. And let's see now, change, shift enter again, and shift enter again. And now you can see difference between previous one and this one. Now it's losing power when it goes 100, goes down, it goes up to 60, and goes down, goes up to 20, goes down, and goes something above 0. Let's change a little bit more, put it 9. Now we have it more, because we did not put 0.8, we put 0.9, so it's a little bit more strength. Okay, this is it for this video. Thank you for staying with me, and in next video we will start animating this. I'm gonna take this visualization, turn it into a dot, a ball, and then we're gonna animate it with a function animation that we have in matplotlib animation. We're gonna import it, and we're gonna do some animations with that ball. One more time, thank you for staying with me. Thank you for checking my channel and subscribing, liking. Your support means a lot to me, and see you in next video.
One moment, please.
Just a note at the end, because we are in container and we are using Jupyter Lab inside Python virtual environment. To exit that, we can go Control C, and we're gonna shut down this Jupyter server. Okay, too late. Do again. Control C. Yes, we're gonna shut it down. Now when we clear the screen, we see we are now only in Python virtual environment. If we do ls, now we're gonna see the file that we were working on it. And to go out of this virtual environment Python, we can do deactivate, press enter, and we are out. As well, we are still in testing Incus container. We can just exit. We're gonna go to root mode, and then when we exit one more time, we're gonna exit now sandbox, our virtual machine. One more note for Linux, because as you can see, I do not have here bar, art menu or anything. I like it like that, clean. You can see clean. No bars, nothing. We can shut down like this. I go into root mode, put a password, and then let's clear the screen. To shut down Linux, you can just go into root mode, and then you type systemctl power off, and that's it. It's gonna shut down this virtual environment. Shut it down more. One more time. Thank you. Bye bye.